Alright, continuing part 2 of part 2. Appendix number 11, sampling and analyzing flue gas. The laboratory test gas samples are to be drawn from the smoke box and suitable for the aspirator of the displacement method of the collecting of over every mercury and other suitable liquid. In general, the analysis should be made immediately after collecting and sample the road test. The gas samples must be collected with some portable gas metal container with a can later between the chemistry laboratory analysis. The most common method of determining the relative percentage of the difference constitutes the flue gases means for the ORSAT or Hempel apparatus. The description of the ORSAT apparatus contained by the American Society of Mechanical Engineer Code as follows. The ORSAT apparatus is portable and the instrument continued in a wooden case removable with sliding doors in front and back. It's shown in the simplest form in figure number 5, consisting constantly with the measuring tube, the burette, and 3 having absorbing bottles of the pipettes. Living bottle together with the connecting tube, the apparatus. The hot bottle measures the tube containing the pure water of the first pipette, and sodium hydroxide dissolved with 3 times the weight of the water. Second, the pyrogallic acid dissolved in the sodium hydrated with the proportion of 5 grams of acid to 100 cc's of the hydrate, and third, orpus chloride. These chemicals are sold in most of the large dealers. Manipulation of the instrument, which can be carried on the other suitable practice of any person familiar with the testing of the work, as follows. After completely drawing out the syrup contained with the supply with the pipe with the sample of the gas, then drawn into the measuring of the tube without opening necessary connections, draw a line with the water to empty itself from the tube to flowing into the bottle. The quantity of the gas drawn and adjusted with the 100 cc's by opening 1-to-1 connection to the pipe is resisting lower the water bottle with the sample that is alternately emitted to the withdrawn with the pipette as ingredients of 1-to-1 absorbed. The first pipette absorbs the carbon dioxide, the second oxygen, the third carbon dioxide. The quantity absorbed in each of these determines the final return of the sample. The measuring burette reading the volume, the percentage of the carbon dioxide is read directly being with the first absorption. Then the other 2 ingredients are respectively different between the readings taken after successive absorptions. Various modifications of the apparatus have been developed. Figure 5 shows your orifice apparatus with the 5 bottles, 3 bottles, 5 bottles, for your collection, which enables analysis to be made with a greater readability with the form and illustration. Figure number 5. The more accurate analysis is obtained with the use of the imperial apparatus. The description of methods may be attained with the reference of the American Society of Mechanical Engineer report of Power Test Committee with the code of 1912, pages 184, 1841, and 1843. Number 12, pressure and draft gauges. For the laboratory, 2 steam pressure gauges are to be used with one necessary. One to be used. One is necessary. There is one gauge is the cab, another mounted on the suitable gauge board, readily accessible to the observer. But the gauges should be substantially corrected, calibrated over the working range of the boiler pressure. For the road test, the one gauge is generally to be used as always in the cab. The standard steam pressure gauge is suitable for this work. Draft should be measured in the following places: the ash pan, the firebox, and the front of the front of the diaphragm and back of the diaphragm. The draft gauges from the ash pan should be preferably 2 or other differential sum of the similar type of in case of the very accurate readings and desired should be graduated to read the maximum at least 1 inch of water or equivalent. Very accurate readings of the draft in the firebox is desired, and maximum inspect draft that the point is not exposed with the 4 to 5 inches of water in the differential draft gauges will be found practical and satisfactory for this work. It is greater draft that are encountered within the firebox, or unless the accurate reading of the ash pan end of the firebox drafting will surface the U-tube will generally be found with the most expedient for this work. In general, the draft gauge for the front end of the reading should be of the U-tube type that made with a reading of from 0 to 18 inches of water. The pressures are generally led to each of the draft gauge through the flexible connection about 1 1/4 inch diameter, which are connected with the steel tubing about such diameter. The open extremity of the draft tube should be as near as possible to the center end of the space which is desired to determine the draft. In setting a differential draft gauge, if necessary, if they are carefully unleveled, and in the end of the case of the U-tubes, they are vertical. The U-tubes will require calibration, except with the desirable check for the markings by measurement. The case of the differential gauge of the the level of which the liquid must be in the zero of the marking there was and no pressure. There's desirable in the case of U-tubes. U-tubes to facilitate making of the observation. U-tubes generally recommended with draft reading since they require least of care and adjustment and of the sufficient accurate for the most work. Possible expansion of the ashpan firebox readings and stated above. Appendix number 13, indicators. Their use of indicator locomotive testing should be consideration under the two heads, laboratory testing and rock testing. The two indicators per cylinder show that in general be used for the work of the diaphragms may be the greatest volume. With the facilitate the work, indicators should be used for the range to allow the diagrams to give it observation. It may be taken nearly as simultaneously as possible. Indicators that continuous card type permanent investigation otherwise impractical for difficult and possibly or otherwise impossible or difficult. The indicators can be conventionally secured on the side of the cylinder and aligned parallel to the motion of the crosshead. The steam connection should be preferably from the side of the cylinder as near as the head as possible. The piping of the cylinder indicator cock should be preferably 3/4 inch pipe. Equivalent internal diameter should be as short as possible, thoroughly insulated to prevent radiation. The cocks should provide the clamps rigidly secured by the cylinder in order to overcome the tendency of the indicators to move longitudinally reference of the driving ridge. One of the cocks of the each cylinder should be of the three-way type through the connection between the steam chest. One indicator should be affected so that the steam chest cards can be taken as required. The reducing motion can be any form to transmit the reducing motion of the piston accurately. Photograph and pendulum motions are most generally used for laboratories and laters will be found satisfactory. Reducing motion will, in general, serve as indicators with one side of the locomotive. A rigid connection from the motion should be brought to as close as the indicators as permissible in order for the card from the connection to the indicator may be short as possible. Indicators, indicator piping, reducing bars should also be supported to prevent undue vibration, eliminating inaccuracy with the diagrams for as far as possible. For road tests, in general, same direction for the road test for laboratory testing regarding the indicator. Notice the practice exemption for the position of the indicators in order for the ensure the clearance of the indicators must in general be mounted to the steam chest of the valve chambers. Due to limitation of the workspace, it's usually possible to be used but one indicator per cylinder. Such in the practices will usually be found satisfactory. It is desirable, however, the two indicators per cylinder may be used. There is sufficient room to install and manipulate the satisfactory of the indicators by the continuous card, although the practice is no means common in road tests. Figure number 6 represents the form of the paragraph motion, which will in general be found in satisfactory road tests, such as changes dimension are necessary for the installation upon particular locomotive. Appendix number 14, individual instruction sheets. Individual instruction sheets should be drawn up for each of the observer, giving the information desired for the testing manipulation instrument. It was subjected to its care rules regarding the collection of the desired data from the log sheet. These instructions should be fastened to the observer log board as they may be preferred in the case of doubt. Alright, let's move this on the drawing to the side. Alright, this is figure number 6, your panographic reducing motion. Reducing bar, rigid, non-adjustable piston on the center, your indicator. Alright, appendix number 15, leakage test. The piston valve hits the dry pipe within the connection should be tested for the leaks. So the person familiar with locomotive operation practice will be able to perform the work in any particular case of the blocking crossheads, removing the cylinder end of the valve heads, blocking the steam ports, adapting such other methods will permit to apply the same air, water, and pressure to this part with begin and tested of leakage and then observing the measure of such leakage. After the satisfactory determined all leakage has been reduced to a minimum, the locomotive may be tested as a whole. Linkage from the time method as follows. The crosshead block with the throttle is open until the parts of the steam system becomes thoroughly heated. Then the throttle is then closed. It means if the pressure gauge or indicators cocks, the length of the time required for the pressure that disappears is noted. In this way, the leakage of the steam system as a whole may be comparatively determined. Alright, appendix number 16, you got your log sheets, a representative collection of log sheets for the use of the laboratory tester shown on pages 82 and 85. On page 92 will be found a convenient form for the log sheet regarding smoke observations. Or you have your locomotive testing plant test number, the RPM, the reversion of lever throttle, sheet number to date, observation time, tank number 1, tank number 2, tank B, total height of water and feed, height of correction, weight delivered boiler, temperature of feed weight, temperature of feed water in lower tank. Locomotive testing, test number, RPM to revolution of the LV, plan of the cab, log, inspector, injector, observer date, sheet number, time, boiler pressure, water level, boiler, injector in action from and to in time, injector in action from time to time, from pop valve to Alright, section D is the test number, RPM, revision of the letter, throttle, temperature, observer date, the number, sheet number, time, drawbar, wet bulb, dry bulb, decalorimeter, locomotive testing plant, test RPM, RVE, LVE, lateral, throttle, sheet number, date, observer, time of the collection sample due from and to carbon dioxide, CO2 plus oxygen, carbon dioxide, oxygen variable to carbon monoxide, nitrogen. Alright, locomotive testing number, time in smoke bunch, front and back diaphragm, in fire ash, in fire, in ash, in firebox, smoke box, laboratory, calorimeter, RPMs, rev count, reading average RPMs. And then the C is your locomotive miscellaneous log throttles. The appendix number 17, locomotive testing plant. The laboratory test described that the coding cannot readily be made unless the testing plant is available with work that may be carried on. Some of the plant is comparatively expensive to install, that they are not very many existing at the present time. A locomotive testing laboratory should be arranged so that the driving wheels of the engine come out of the revolving support, so that the load applied with the engine, some of the form of the brakes dynamometer should be connected with the drawbar with the engine, measuring the amount of the drawbar. In addition, there should be a measuring tank that the spark catcher and such other equipment make the necessary satisfactory conduct tests. Appendix number 18, 2 pyrometers necessary for ordinary laboratory road test. 1 registers the temperature inside the smoke box, 1 inside the firebox. In most cases, the pyrometer mercurial thermometer having a range of about 200 to 900 degrees Fahrenheit will serve as the register at all smoke box temperatures. In some cases, the pyrometer having a maximum reading high as 1200 degrees Fahrenheit will not be necessary. Mercurial thermometers recording temperatures below 900 and 1000 degrees Fahrenheit are comparatively inexpensive and easy to maintain, and usually found satisfactory for the work. Generally, the pyrometer measuring the firebox temperature will need to have only the maximum reading of 2,000 degrees Fahrenheit. However, the maximum temperature of the firebox may range upwards from 2,000 degrees Fahrenheit to as high as 2,700 degrees Fahrenheit. The pyrometer electrothermocouple type of the resistance that will be found satisfactory at high temperature measurement. In case of the very high temperature encountered with the pyrometer optical type that may be found desirable, high temperature measurements should be made with the supervision of making inspectors experienced in such work, and the general pyrometers with the upper range of 2,000 degrees Fahrenheit to 2,200 degrees Fahrenheit much be easier to calibrate, maintaining with these in the high range. Warner's optical pyrometer, Uliction's pneumatical pyrometer, Bristol thermoelectrical couple pyrometer, Ferry's radiation pyrometer are among those referred. The full description of the directions can be found with the trade catalogs, various dealers, and chemical physical testing apparatuses. For special purpose, additional pyrometers may be required. Appendix number 19, road test measurements, fuel measurement. Satisfactory method determining the amount of the coal burned during the locomotive road test is outlined as follows. Previous to the run, there be weighed out in the smoke holding the 100 pounds, sacks holding 100 pounds each of enough for the coal to easily make the run. Platform scales will be round conveniently to the work. The weight of the coal is fired during the run must be stored separately in a tender form, unweighted with regard with the firing of the coal, sealing the maintenance running conditions, and stopping the starting end of the running and the road test. Since the number of the 100-pound sacks of coal in the tender before the run started is known, the amount of weight left in the tender at the end of each run subtracted from the original amount, giving the direct amount of the coal fired during the test. Or water measurement. There are two general methods measuring the steam of the consumption of the locomotive during the road test: the measuring of the water in the tender cake, other water measures in the suction pipe with the injector. The former method is accepted. The most reliable is form the observation when the water in tender tank that the final determination of water consumed with the locomotive is to be made. The meter reading are in general used to check the tender tanking readings and in order to reduce the possibility of making large errors at a minimum. There are two general rules and methods determining the amount of water in the tender tank at any time: the use of the float and the graduated scale by the use of the gauge glasses with the attracted with the graduate scales. And if a float is used, they should be secured with a secure way that operates approximately through the center of the gravity of the water of the tank, and the metallic float, properly guided with the carrying of the suitable pointer scale, will read round satisfactory. The scale of the corresponding with the float should be such dimensional that the maximum and minimum observation can be taken under due difficulty. The rod should be preferably graduated in inches and tenths of an inch. The gauge glasses are used with the two glasses that should be installed with the opposite corner of the tank. This must unload long enough for the take maximum minimum readings must be tapped in the tank of the top of the bottom of the connection made by the rubber hose. The glasses should be thick and should be enclosed by wood, leaving just enough to have opening to make the easily readable. The marking should be made directly on the glass. Should be preferable with inches, 10 of an inch. The calibration of the tender tank readily accomplished with either the above form of the apparatus for the method is variable. First, the filling of the tender tank with the small tank of the platform scales. Second, determining the various amount of water in the tank of the putting into the tender for the track scales. Found from this due to the obtained calibration of the curve of the tender tank that being plotted with writings of the marking of the goods, marking of the rods and gases, the absence viscousness, the weight of the meter water of the tender tank against the former ordination. With the gauge glass at the reading of the necessary that the tender and be level with the calibration taking place. While the readings are being read, the glasses should be read simultaneously. Serve the single reading. The average of these two percentage will serve the value of the determining the amount of water in the tender tank. It's usually desired to use the water meters to check the tank of the readings. There may be standard for them the water meter, which is possible calibrating with one of the degree of the certainty. The meters are attached with a suction pipe in such a way to make them most easily readable while running. The receptacle must be placed under the injector to catch the overflow of the amount of water collected in this may be thrown back into the tender tank. The correction may be made by weighing. Alright, appendix number 20, determination of character of the smoke. Most common method to determine the character of the smoke must be used by the Ringelmann chart. Figure number 7 shows the photographic reproduction of the Ringelmann smoke chart used by the technological branch of the United States or Geological Survey. Use the chart. 4 cards are ruled similar to those shown. The width of the lines of the specific river given below, placed in a horizontal row about 50 feet through the observer and the line between him and the chimney, together with the 2 other cards, one of which is white and the other solution, the other is solid black. The observer glances rapidly with the chimney and the cards were judged. One corresponding with the color designates with the smoke. He makes the observation every minute, makes these observations every minute, often or oftener, to desired record number of the carding representing with the character of the smoke instant observation. The result are then plotted in the chart with the variation geographical. Are shown graphically. The lines in the card 1 through 4 respectively 1.23, 3.7, 5.5 millimeters thick, spaces of 9.7, 6.3, and 4.5 millimeters. On page 92, this modification of Ringelmann charts has been employed with the University of Illinois, both in connection with the stationary locomotive boiler trails. Alright, so here's your different boiler content spaces, your Ringelmann charts. A differing expiration chart, and the Ringelmann chart. Other methods making smoke determination sometimes been employed with advantage of often unsatisfactory because of the expanse of the account of the requiring delicate and intricate apparatus. Alright, appendix number 21, speed indicators and stroke counters. The speed indicator is generally necessary for the laboratory test of use, such as controlling the brake and assisting in the keeping the locomotive predetermined speed, and road test the instrument of the recording type with giving the record of the speed of the train at all times. The dynamometer of the car achieves the speed indicator for the cab is necessary, but it is often desirable. Speed indicator generating electrical type is recommended for this work. Some of the form of the reliable striker stroke counters may be used to register the number of the revolutions made for the drivers. It may be attached with the crosshead or the suitable part. In case of the road test, the stroke counter may be provided with the register the number of the strokes made by each air pump thoroughly with a run. Alright, your number 22 is steam loss measurements. In general, the amount of steam used by the air pump to the pop valves, calorimeter with the auxiliary apparatus, the motion of the satisfactory determined with the test, condensing the weight of the apparatus for the comparatively small armature apparatus. Such tests may be made in conducting exhausted steam to a tank condenser and scales and weighing the exhausted steam in this way. In case the condensing steam apparatus is not as available, the steam loss determination may be made as follows. Your air pumps. Reports of tests have shown that the steam accumulation of the air pumps are generally available with either manufactured from the other sources, and it can be used estimating amount of the steam used of the air pumps. Pop valves. Firing the locomotive to each such an extent that using wood or forced draft or both, the steam pressure will be maintained for the considerable length of the tire while the valve is popping off. Determine the amount of steam passed with the pop-up valve, the amount of water fed with the boiler, changing the water level in the boiler. The test carefully carried out with the water, checked for the satisfactory result, and one honor and generally obtained. Alright, your calorimeter. The area of the steam orifice of the calorimeter is known as steam loss, and point at that point, it can general satisfactorily determine the Napier's formula, which is MO equals P times X divided by 70, which is M is the steam pounds escaping through an orifice of the square inches under pressure of pounds per square inch in 1 second. Our appendix number 23, thermometers. One thermometer is required to measure the temperature of the air surrounding the locomotive. One measures the temperature of the feed water, with another measures the temperature inside of the well with the throttling calorimeter. Another thermometer of the bulb in which the cap is being wrapped in the water-soaked in wick is generally to be determined with the wet bulb temperature. A hydrometer and swing tap are preferred with the stationary wet and dry bulb thermometers. The thermometers will require, if desired, to obtain the temperature reading with the receiver of the branch pipe and exhaust passages. The two thermometers measuring the type of the air and should be graduated to read 0 degrees to 150 degrees Fahrenheit approximately over the range. The four thermometers that are used measuring the temperature calorimeter, the receiver of the branch pipe and the exhaust should be graduated to read 100 degrees to 400 degrees Fahrenheit substantial over the range. A high ranger will be required when superheated steam is to be encountered. And that is the rest of the book. That's the rest of the book, and this was French Wilson, the Code of Conducting Steam Locomotive Tests.